What if the universe has a secret, a hidden direction, a cosmic axis woven right into the fabric of reality? For nearly a century, our picture of the cosmos has been built on one powerful idea, that on the biggest scales, the universe is the same everywhere and in every direction. No up, no down, no special way to spin. It's a kind of cosmic democracy where no place and no direction gets special treatment. But what if that fundamental rule is wrong? For years, a strange and deeply controversial anomaly has been lurking in the data from our best telescopes. A hint that galaxies aren't just spinning randomly, but are part of a cosmic dance, with a slight but persistent preference to twirl in one direction over the other. This observation has been so tricky, so hard to pin down, that it's been stuck on the fringes of cosmology. But now, with the jaw-dropping power of the James Webb Space Telescope, we're on the verge of either finally putting this weird idea to rest, or confirming a discovery that would make us rethink everything. Because if the universe does have a preferred spin, it gives new life to one of the most radical, mind-melding theories ever proposed, that our entire universe exists inside a black hole. To really get why this is so huge, we need to talk about the bedrock of modern cosmology, the cosmological principle. It's a simple but profound idea that's been backed up by observation after observation. It says the universe, on large scales, is both homogeneous and isotropic. Homogeneous just means that no matter where you are in the cosmos, things look pretty much the same. There's no special center of the universe. Isotropic means that no matter which way you look, it all appears identical. Think of it like being on a boat in a vast foggy ocean. Every direction looks the same. And this isn't just a philosophical preference. It's the glue that holds our models of the universe together. The best proof we have is the stunningly uniform cosmic microwave background, the afterglow of the Big Bang. It tells us the universe started in a state of incredible balance, and that the laws of physics are the same everywhere. This lets us take what we see in our tiny corner of the cosmos and apply it to the whole thing. Without it, cosmology would be nearly impossible.
But what if that perfect symmetry has a crack? What if there's a subtle pattern hiding in all that chaos? For more than a decade, a handful of astronomers have been pointing to a troubling crack in that very principle. A researcher named Lior Shamir, using massive piles of data from sky surveys like the Sloan Digital Sky Survey and Pan-STARRS, started noticing something odd. When he cataloged the spin direction of hundreds of thousands of spiral galaxies, the results weren't a perfect 50-50 split. Instead, he found a slight but stubborn imbalance. In some parts of the sky, more galaxies seemed to be spinning clockwise than counterclockwise, and in other parts, the opposite was true. This created a pattern across the whole sky, something astronomers call a dipole axis, like the north and south poles of a magnet. It suggests the universe itself might have a preferred axis of rotation. This claim was, and still is, deeply controversial. Many scientists argued it could just be a fluke, an error in how the data was automatically analyzed, or maybe some kind of observational bias we just don't get yet. The effect was tiny, and proving it required huge data sets and painstaking work to rule out other explanations. One of the big counter-arguments is that our own motion could be creating a cosmic illusion. As our Milky Way galaxy zips through space, the Doppler effect might make galaxies spinning one way look a bit brighter or easier to spot than those spinning the other way, messing with the stats. The debate has been locked in a stalemate. The evidence for an asymmetry was tantalizing, but not nearly strong enough to overthrow a century of cosmology. To really settle it, we needed a new tool, a telescope so powerful it could not just see nearby galaxies, but peer back to the dawn of time itself. And that's exactly what the James Webb Space Telescope is for. With its enormous mirror and unmatched infrared vision, JWST can see the very first galaxy starting to shine just a few 100 million years after the Big Bang. This gives us a direct window into the early universe, letting us test our most fundamental ideas.
The logic is simple. If the universe was born with a built-in spin, that preference should show up in the very first galaxies. In fact, some analyses predict the asymmetry might have been even stronger in the early universe, slowly evening out over billions of years. And preliminary analyses using JWST data have started adding fuel to this fire. An early look at a small patch of sky, known as the Hubble Ultra Deep Field, identified 34 early spiral galaxies. Of those, it was reported that 24 were spinning one way, while only 10 were spinning the other. Another analysis of 263 galaxies from JWST's Advanced Deep Extragalactic Survey, or JADES, also reported a significant imbalance, finding that about 2/3 of the galaxies were spinning in the same direction. Now, let's be crystal clear. These are very early days. The sample sizes are small, and these findings need to be double and triple checked by the entire scientific community before anyone declares victory. But for the first time, we have a machine that can give us a definitive answer. So what happens if JWST confirms it? What if the universe isn't random? What if it was born spinning? To explain that, we have to go down one of the most speculative and fascinating rabbit holes in all of physics. The theory is called black hole cosmology, and it suggests something that sounds like science fiction. Our entire universe is the interior of a black hole that exists in a higher dimensional parent universe. This idea isn't brand new. It's been explored for decades by physicists like Nikodym Poplavsky. But it's getting a fresh look because of this potential discovery of a cosmic spin. Here's the basic idea. In standard physics, a black hole forms when a massive star collapses into a point of infinite density, a singularity. But some physicists, Poplavsky included, argue that a true singularity might be physically impossible. They use a modified theory of gravity called the Einstein-Cartan theory, which includes a property of spacetime called torsion. In this model, as matter collapses inside a black hole, torsion creates an immense repulsive force that stops it from being crushed into an infinitely dense point. Instead, the matter hits an unbelievable but finite density, and then it bounces. This big bounce would be so powerful that it would create a brand new expanding universe on the other side of the black hole's event horizon. From our perspective inside this new universe, that big bounce would look just like the Big Bang. And here's the crucial link. Black holes in our universe are almost always formed from things that spin, like stars, so they spin. If our universe was born inside a spinning black hole, it could have inherited the rotational axis of its parent. That ancient spin would be woven into spacetime itself, subtly influencing the motion of matter on a cosmic scale. It would provide a natural, if mind-boggling explanation for why galaxies might prefer to spin in one direction. As wild as this all sounds, it's not just a cool story. It offers potential solutions to some of the biggest puzzles in cosmology. For one, it could explain the arrow of time. The one-way trip matter takes across an event horizon, you can fall in but you can't get out, could be what gives time in our universe its forward flow. It also neatly dodges the problem of the Big Bang singularity. In the standard model, the universe began from an unphysical point of infinite density where the laws of physics simply break. In black hole cosmology, the beginning is a bounce, not a singularity, a violent but physically describable event. And what about the multiverse? This theory suggests that every single black hole in our own universe could potentially be a gateway to a new baby universe. We could never see or interact with them, hidden forever behind their event horizons, but it would mean that universes are constantly being born, nested inside each other like a set of cosmic Russian dolls. Our universe wouldn't be a fluke, but part of a vast, endless ecosystem of creation. So where does this leave us? We're standing at an incredible crossroads. The James Webb Telescope is collecting the very data that could either cement the foundations of our standard model of the universe or crack them wide open. If this whole galaxy spin anomaly turns out to be a statistical ghost or an observational error, then the cosmological principle will stand strong and the story of our universe remains mostly the same. But if Webb confirms that the universe has a preferred axis, that it was born with a spin, it will spark a revolution in our thinking. It would be powerful, though not definitive, evidence that something profound is missing from our origin story. And the theory that we live inside a black hole, once a fringe idea, would suddenly become a compelling, if still highly speculative, explanation. But the answers won't come overnight. It will take years of painstaking observation and analysis to settle this. But for the first time in history, we have the power to genuinely test these reality-bending ideas. We live in an age where our deepest assumptions are being put to the ultimate test. The universe, it seems, is far stranger and more mysterious than we ever dared to imagine.